Today we're starting 5.2, which is about rates and unit rates. I want you to go ahead and let's look at this problem. It says find the missing values in the ratio table and then write the equivalent ratios. This is just like our lesson that we did yesterday. So remind me, guys, if I am going from top to bottom, what do?
Divide.
I divide. Good job. And the opposite, if I'm going from the bottom to the top, what should I do?
Multiply.
Multiply. So we're going to always start with this first one that we have right here. I'm going from a 10 down to a 4. What operation do I need to do? Divide. Guys, as a decimal, simply because this one is a decimal, we're going to get our value of the ratio to be a decimal. What is 10 divided by 4?
2.5.
2.5. So that is the value of my ratio. Remember, we get to fill that in because this is an equivalent ratio table, which means everything is equal or equivalent. So we need to write that 2.5 all the way across. Okay, let's go to the next one, Austin. This one right here, I'm starting at the top and going down to the bottom. So what should I do? Divide. What is 18 divided by 2.5? All right, very good. It is 7.2. Who would like to do the next one for me? All right, Maylin, we're going on this one from the bottom to the top. What do I have to do?
Multiply 6 times 2.5 and I'll get 15.
Okay, we get 15. And let's go on to the last one. I'm going from top to bottom. What do I have to do?
Divide.
Divide. Zaria, what's 22.5 divided by 2.5?
9.
9 is correct. Now remember, the last thing it asked us to do is to write the equivalent ratios. So the very first one over here is going to be 10 to 4. Sarah, what's the next one? 18 to 7.2. Olivia, what's the next one? 15 to 6. And Elena, what's the final one? Very good. 22.5 to 9. And then go ahead and box it in. And those are our equivalent ratios.
I love ratios.
All right, so a few terms that we're going to be using today. The first one is a rate. Now, this is a kind of ratio. It says here that it is a comparison or ratio of two quantities that are in different units. Notice my two units here. The first one on top is what unit, class?
16 miles.
Miles, okay? What unit's on the bottom?
4 hours.
Hours, okay? So the rate here, it's a ratio that compares two different units, okay? Next up, a unit rate. It compares a quantity to one unit of another quantity. Read me what it says there in parentheses.
It has a denominator of 1.
Okay, I want you to take your red pen and underline that word right there. This is emphasizing the unit rate will always have a denominator of 1. If you notice right here, 4 miles per 1 hour. So the denominator will always be a 1 whenever we're talking about a unit rate. Finally, we've got equivalent rates. We've learned the word equivalent. What do we think that means? Equal, okay? So they have the same unit rate. If you look right here, this says 16 miles for every 4 hours. And I'm saying that that equals this right here. Do you know how I can get from 16 miles for every 4 hours to 4 miles for only 1 hour? How would I get from one of those to the other?
Divide.
You divide by what number?
4.
Good job, okay? So notice I've divided by 4, and I got this. Down here, I divided by 4, and I also got that. So those two are equivalent, and those are considered equivalent rates. Problem number 1 says, a nutrition label shows that every 1/4 cup of tuna has a 1/2 gram of fat. All right, so A says, how many grams of fat are there for every cup of tuna? Notice up here that it says right there, I've got 1/4 of a cup of tuna. Does everyone see that? Okay, so how much do I have of fat? A 1/2 of a gram of fat. So what we're going to do is we're going to go ahead and write a ratio, okay? It says grams of fat to cup of tuna. How many grams of fat do I have?
100.
Okay, notice it's the second part. I have a 1/2 a gram of fat. Now I'm writing a ratio here, a 1/2 a gram of fat to how much tuna? 1/4 cup of tuna. Very good. Now if you remember from yesterday, we said you could put the little word to in between them, or we could use a what?
Division.
a division or a fraction bar. Okay, so that means 1/2 divided by 1/4. Another way that we can write this, if you remember, is like this, 1/2 divided by 1/4. Am I allowed to divide fractions? No, so what do I have to do?
KFC.
I've got to do the KFC method. Keep the first one. What do I do to the second? Flip the second one and then change the operation. Joseph, is there anything here I can cross-reduce?
2 and 4.
The 2 and 4, all right, they become a 1 and a 2. And what is my answer, Riley?
2.
The answer is 2. Now here's the difficult part. Deciphering or interpreting, what in the world does that 2 mean? So when I go back to my original question, this is what it says. How many grams of fat are there for every cup of tuna?
2.
So you're simply going to say, in a sentence, there are 2 grams of fat per 1 cup or every cup of tuna. All right, now if you look at problem B, it looks very similar to problem A. Can anyone tell me what the difference is between the question that I asked in A versus the question that I asked in B? They are switched, okay? It says how many cups of tuna are there for every gram of fat? In the other problem, you'll notice that it talked about grams of fat first, and then it talked about cups of tuna second, all right? But when I am reading my problem, I've got to read it from left to right, and I have to start with the cups of tuna. How many cups of tuna does my original problem tell us that we have?
1/4.
1/4, so that's going to be 1/4 per 1/2 gram of fat, okay? I want you guys to try to do problem B on your own. All right, let's see if you got the same thing. Remember, this means to divide 1/4 divided by 1/2. We have to do the KFC method, 1/4 times 2 over 1. It can cross-reduce. And then what's your answer, guys?
1/2.
1/2. Is there anyone who can help me interpret what that 1/2 means? What do you think, Kaylee?
There are 1/2 cups of tuna for every gram.
That is perfect. There is 1/2 cup of tuna per 1 gram of fat. All right, problem number 2. There is 1/4 gram of fat for every 1/3 tablespoon of powdered peanut butter. Okay, now powdered peanut butter, this is like for a shake, like a protein shake or something that you're putting into it, okay? How many grams of fat are there for every tablespoon of the powder? When it talks about every tablespoon, how many tablespoons is that talking about right there?
Every tablespoon.
1. Only 1 tablespoon. Every tablespoon means 1 tablespoon. Talk to your partner and see if you can figure out the answer to this. All right, I was impressed by many of your answers. Let's go ahead and talk through it. If I've got a 1/4 gram of fat for every 1/3 tablespoon of powdered peanut butter, what do I start with? What's my ratio I'm starting with, class?
3/4. 1/4.
1/4 divided by
1/3.
1/3. Okay, you start with what you had first, the gram of fat, and then divide it by the second thing, the 1/3 tablespoon of powdered peanut butter. That means 1/4 divided by 1/3. We have to make sure that we use the KFC method. What is my answer?
3/4.
3/4. Is there anyone who is willing to share with me how you interpreted what 3/4 means? Connor, what do you think?
There are 3/4 grams of fat per 1 teaspoon of powder.
Okay, there are 3/4 grams of fat per 1 tablespoon of peanut butter.
Peanut butter.
The one thing I am looking for is your units, okay? Make sure you know this is the grams of fat, and this is the tablespoon of that powdered peanut butter, okay? If you have the wrong units, then your answer is incorrect. So make sure you've got the correct units there. Next problem for today. It says find the unit rate. How have we been doing this? We've always started with the first one, and then we divide the second one. So what this is saying here is $1.32 for 12 ounces. So what do you think that I should do? Kaylee?
Put 1.32 to 12.
$1.32. Okay, she says put it to 12. But the way that I like to see it, because it's a way that we can actually do the work, is to put the what? Let's put the fraction bar, okay? Divided by 12 ounces. I'm just going to do OZ for ounces. Okay, so now that we see this fraction bar here, what operation am I doing, class? I'm dividing. Okay, this is a calculator chapter. You can stick that into your calculators and let me know what you get. What'd you guys get?
11 cents.
Okay, so I hear a lot of people that said 11 cents. Now let me explain to you what I need, okay? It's asking for a unit rate. Go back to your notes that we just wrote down about unit rate. The unit rate told me you have to have a denominator of what? Of 1, okay? Do you see any denominator there? No, okay, so here's what I need to do. I need to understand, when I am doing this, I'm trying to get a denominator of 1, so I'm dividing by 12 on top, dividing by 12 on bottom, okay? So guys, what is, let's look at this part, 12 ounces divided by 12? 1 ounce. So all this answer is telling us is that's going to be 11 cents per ounce. How many of you have ever seen those things at a grocery store where it might tell you a little thing right there and you can understand or see how many ounces you're getting for what you're paying for, okay? A lot of times people will buy things from Sam's or Costco because you can get a better deal per ounce, all right? So listen, we're going to stop our lesson here for today, but we will pick this back up on Monday.